Hello guys. So in the previous session we have discussed a little about NAT and now we are going to learn DNAT this time. Okay, so we have gone through the SNAT and that we are little confident, and DNAT is referring the name as destination NAT, right? So what we will do, we will try to NAT the destination as per the requirement. So the source NAT is basically whenever we are inside the enterprise, it's like from this site we are doing that one, right? We are having the source IP addresses, and those source IP addresses are being translated to some other IP addresses. Normally it is in the public IP addresses, and that public IP address goes to the internet. So that is the basic use case of the SNAT. While in the destination NAT is something like some users on the internet, they are trying to access an internet on your server, which is DMZ server inside your organization, right? So how they will try to access that one, that is basically done via DNAT. And normally what we do via this static NAT. This is done via static NAT. So this source NAT is basically a hide behind gateway, or we can say the PAT basically we are using. And while the destination NAT is a one-to-one NAT, and we are using the static one for that purpose. So how it is happening actually, let's take one use case. Let's suppose this is a one user having any XYZ IP address, and he's trying to access any web server. Let's suppose you have given a public IP address or something 100.1.1.10, let's suppose. Okay, so now this user will try to access this IP. So once this user, right, this user A will hit this 100.1.1.10 IP address in their URL or whatever. Let's suppose if they are using the HTTP service, then obviously they will use the URL, and if they are using any of other services like FTP or mail services, then they will use appropriate application or the ways of use cases, and they will try to reach the IP address. But the main purpose is that they will try to reach our public IP, this 10.1.1.10. Now what this firewall do, or in fact we will do as an administrator, that we will translate this IP to the IP address of the web server. So we will use static NAT here in this device, and we will translate that IP address 10.1.1.10 to 172.16.1.10, which is the IP address of the web server. That's what we are going to do here. So this is the basic use case of the destination NAT. So I will explain more that how or what is the possibilities, and what are the complications in using that one. But before that, let me go to the lab and just show you that how you can access this feature or reach the DMJ server. But obviously in our case as well, we don't have the user in the internet, so I will try to replicate from this machine. I will use this IP address 10.1.1.51 as a public IP address, right? So what I will do, I will use this 10.1.1.51 in this machine, which is inside a VM, right? Let me open it. I think it's already opened. Okay, and not a problem. Let me explain a little more. And similarly, we will try to reach this. And I have taken a web server here. So this web server is also basically a Cisco router, and I have named it as a web server and have configured the web services in this router. So I will just configure all those things. You will see that how we can configure the web server application on the router. So that is because that's testing point of view or a demo. So that's why I will show you. But in the production environment or in the real life, there will be really a big server, any of the server, and you will accessing those services. But the concept is same because you're not the guy who is configuring the web server. You always get an IP address and just uh, configure it, right? Your job will be to do the NAT for that one. So we will not go how to configure a web server, do Linux configuration, do VMs and all. We are not going to do that one, right? We are just playing with the IP addresses. But obviously, to give you a real feel of a web server, we have to use that service. So for that purpose, I will just configure it and show you. So let me open my lab here. Yeah, this is my lab. Perfect. So first thing, I will going to configure the web server here. So this is a router. So as usual, it is giving me a dialog to configure the router. I will say it as no that I will configure by myself here. Okay. And it is not coming here. Yeah, here it is. Enable and show IP interface brief. There are no interfaces configured as of now. So what I'm going to do, I'm going to configure the interface. Configure T interface G 0/1 or 0/0. I don't remember. Let me just cross verify it. Yeah, this is interface G 0/0. So I'm giving this IP address as 1.10 here. Okay. So IP address 172.16.1.10 and the subnet mask as usual. Okay, so the first thing is then, and there's no shutdown. Another thing is that we have to give an IP route so that whenever the any of the IP packet hits this router, it should get a return path so that we can get a reply to the computer. So for that purpose, we are going to a default route 0.0.0.0, and if any of the packet comes, then please forward it to 172.16.1.1. And this 1.1 IP address I have configured here on this interface, Ethernet 2. So whenever any packet comes to this 172.16.1.10, and if it wants to go back, then obviously it will forward to this interface. And we will have appropriate routing on this one and it will forward it to the computer. So this is just to reverse path. Now the job is to configure the web server. So first thing I want to make the name router to the web server so that you can give a feeling of that one. So for that one, the command is host name, and I'm going to give it name as a web server and not the router. Okay, so the host name is web server. I think you might not be seeing this one, but I don't want to stop my recording and stretch it a little. I think please bear it with me. And next thing is configure the web server. Yeah. So the command is IP HTTP server. Okay. Once you hit enter, you enable the HTTP service on this Cisco router, and your Cisco router becomes a web server. And next thing is that we have to set the authentication. So IP HTTP authentication I will set as a local. Local means that whatever the configuration or the any username and password checks that will be done locally on this router, right? Because some of the times we also configure TechAct server or the Radius. These are the remote authentication server. Whenever any of the request comes for authentication on this router, then it is going to the uh, TechAx or the Radius server. But this time I'm not going or making it so complicated. just authenticate it locally. But if you are going to authenticate it locally, you have to set a username and password on this router. So for that one, the command is username. It's not taking the name. Why it is not taking? And username is not taking. Okay, let me, yeah. So the main thing is that I'm not getting the full name. So username and I'm creating as a Cisco here, and I'm creating for the max privilege, maximum privilege, map privilege 15, and the password I'm putting as a Cisco. Okay, so this is the username I have created with the username Cisco, as well as the password will also be the Cisco, right? It's okay. And I think my web server is ready. Exit, and let me write this configuration as well, so that in case if this goes down, then also the configuration remains on my web server. Now the next thing is our firewall, right? So first thing, we have to configure this interface 172.16.1.1. So I will log in this. I think it is, I have already configured it, but let me show you, because I remember it should be there. Just hold on, guys. Okay, so what I'm going to do, I have to log in this device 10.1.1.51. Let me close this one. Oh, let me open the Chrome. So the IP address of the gateway was 10.1.1.51, and let's wait to open it. It will or it will not. Let me try to ping as well. If it is having some issue, it will let me know. Although it should not be having any issue. Yeah, it is pinging, but I don't know why it is not opening here. Sometime it is, very rigid that I will not open, but yeah, it comes now. Admin 123 is my password. And if I go to the network interfaces, because this is my gateway, right? You see that this is gateway. And if I go to the network interfaces, uh, Ethernet 0 is 10.1.1.51, and this one I have already configured, right? And this IP address is for the internet, so that we configured it via DHCP, and we did it in the previous session. So this one I have configured, but let me show you that how we do it. You just have to enable this port. I have given the name as DMZ server, and just put the IP address 172.16.1.1 and set OK. Once you set this IP address, the next and very important task you have to do, that just go to the Smart Console, go to the gateways and server, right? And we have added our gateway to the Smart Console. Just double click on it, and going to the network management, what you have to do, you have to get this interface, get interfaces with topology or without topology. You do anything, it does not matter. But the most important part is that you should do it. Why I do it? Because if you do not do it and you have just added your interface might not be visible here. So once you click it here, like interface, get interface with or without topology, right? So it will just ask you to accept that interface. Once you accept it, it comes here. And if you have not that done that, it will, not come here. So that's why we normally do it and put it okay. Why I have, because I have already done it. But if you are trying it by this one and if you do not do this get interface, you might face some issues, and it not working as intended. Next thing is that we have to add a web server, right? And we have to add a NAT policy for that. We call it as a destination NAT. So for that purpose, we have to create an object. new host. I'm going to give the name as a web server. IP address will be 172.16.1.10, right? And I want it to be NATed with the IP address at automatic. So we are very good on this, that what is the automatic and what is manual. So whenever we say it automatic, the automatic NAT rules are created and they are added in the NAT policy. And whenever we are having the manual, so we have to set all the things, what is the source IP, what is the destination IP, what is the pre-netted IP, what is the post-netted IP. So to avoid those things, we are just using the automatic address translation rules. And the most important part, this time we are not going to use hide, means that we are not going to use the dynamic NAT. We are going to use as static NAT this time. And how it is going to be translated, please translate it to the my gateway IP address 1.51. So gateway IP address is this one, 10.1.1.51. Means that from this computer, we will try to hit this 10.1.1.51, and in place of that one, our request will travel to the web server, and we will get response or the web page from the web server. Okay, so let me go to the smart console here, 10.1.51, and hit it. Okay. And the NAT rules should have been created. Yeah, so these rules have been created. These are automatic rules. You see that it is all automatically showing as, that automatic rule. And whenever we are having the manual rules, we can add later on. So I will discuss manual later on. So here the source is any, from any of the source, the going to the web server. So web server is our 172.16.1.10. So please translate the source, let it be as an original, and the destination should be the web server static, that it should be go to the 172.16.1.10, right? So the same thing is valid for the reverse case, that whenever the reverse is coming from that web server, so whenever the request is coming, because obviously whenever we are sending any packet or sending a request for a web page to the web server, then web server will reply for that. So how that packet will travel, that will be done via this, that from original source, if it is a web server, and if it is going to the any of the destination, any of the service, please translate it to the 172.16.1.10. This is translated source, but the what is the translated as destination? Obviously, from where it was received, please send to the same destination. So it was initiated from this IP address 10.1.10. So the destination will be the same as 10.1.10, because whenever the request was going from here to there, right? So when the request is coming from here to this one, so on that time, the source IP was 10.1.1.10, but when the reply is coming back, this will be the destination IP. Destination IP will be the 10.1.1.10. So they got reversed. So that is normal IP routing. There's nothing no complicated on that. And next thing, yeah, this is the NAT policy is done. Now if you want to access the web page, then can we access it now? Let me show you. We are hitting the 10.1.1.51, but right, you see that right now whenever we are opening the 10.1.1.51, it is opening the Gaia portal of our gateway. But let me just do it now. What happens this time? It's still going to the Gaia portal. Why it is not going to the NATed IP? Because we do not publish the policy, whatever we have just created. But before that policy creation, what we have to do? We have to, publishing the NAT policy, we have to create a normal policy that should allow the traffic to pass through the firewall. Obviously, we have created NAT that this specific IP should be translated to the some other IP, but will that traffic be allowed through our security policies or not? No, right now it will hit to the cleaner rule and that packet will be dropped. So for that purpose, we have to create a rule. Let me create it. Or I think with the internet network, let me just check because it might hit this internet rule as well and it should work. Name is internet, source is internal network, that is okay. Destination any, VPN any, services any. I think it's okay. Even if we publish it, it should hit this rule and it should work. Let me just check it. If it not, then we will try some other ways. Policy, publish and install. But normally, in the some other cases, you have to create a specific rule for that purpose for a web server, and that hit that specific rule, then only the services comes. But for our use cases, it is working very fine because it is going to hit this policy. Now I'm going to open my Chrome here and unable to connect. You see, it is giving an error because this time the service request will go to the we can say our web server HTTP because I have enabled HTTP, not the HTTPS, the HTTP 10.1.1.51. You see, and now it is asking for the username and password because this is has been redirected to the our web server, and the password and username and password we created, that was Cisco and Cisco, and we should be able to open the web page. So this is the by default page of the Cisco router because they have just a demo page they have in their system, and it always shows like that one whenever you want to test any of the web servers type of things. So that is default page. If it is accessible, it means that the web services are running in your we can say the router or the web server. Perfect. So that's how it is the destination NAT. But let me just explain you some more concept, right? That what can be the possibilities of these things, that how these are making, because these are the normal scenarios and they not always fit in the real environment. So, or what problems you can see in the not problem, in fact, the I can say the combinations or the options available, how we do it in the production environment or the real life, that I'm going to discuss. Okay. So in the real environment, what you will see that you are not having only one web server. You can have multiple web servers running on this one. Let us suppose you are having the three web server running here, 172.16.1.11 and .10, or it can be have .13, 172.16.1.13, right? And here there are can be multiple users running the trying to reach these web servers. So the request is coming on this gateway, right? And you can just do the natting according to the ports. It's like if any of the service or the IP address that is coming, first thing is that you can just do static NAT as we discussed, right? You can just do just 100.1.1 web server request is coming to .11 and 100.1.1.2 if any of the user is requesting to this server, this IP, public IP, you can NAT to this IP address. So that is obviously the one case, that one-to-one mapping we can do, that is IP to IP. The another thing what I just say you, out of that static one, we can also do the port wise mapping. It's like that we are having only one public IP. We are not don't want to waste the multiple IP addresses, right? 1.1, we are having just only one IP addresses. But the thing is that if that user is having the uh, want to access the web page or having the port number 80, so whenever the request is coming on this firewall for the port number 80, please NAT it or forward the request to the server having the IP address .11, right? What if any of the user is trying to access of the request that is coming for port 23? Then if the request comes to this firewall for port number 23, please forward it to this .10. If the request is coming for the port number 25 or any other port, please forward it to the .13. So that's how we can do in our firewall, right? So this is just a benefit that we can forward the traffic based on the port numbers. We can do the mapping according to our requirement. But what if the two servers are running the same port numbers? It's like this server was meant for port number 80. What if we are having the high load and there is one more server dot 14 is also running port 80, and if that user is requesting and that request come for that port 80 on this one, now our firewall is not able to decide whether he has to forward it has to forward the traffic to this server or this server. For that purpose, the load balancer comes in the picture. There is a equipment load balancer. So there are multiple vendors like F5, Citrix. So they are running a load balancer. So that comes in the picture. Means our firewall is not capable of handling such type of traffic. But yes, for the port wise bifurcation or division, that which server to forward, that we can do it here. That one thing. And another thing is that one, let's suppose you say the, because that was just one-to-one mapping, and sometimes we don't have just one IP address. We are having one complete subnet for that purpose. How to handle such type of things when we are having the multiple subnet? So in that case, what happens? You can just let me minimize it and go to the my desktop. If I get more space here, no, let me do this way. Yeah. Yeah. So how is going on here? Perfect. So let us suppose you are having the IP address 10.1.1.1 that is normally mapped to any of the IP address like 100.1.1.1. That is fine. But what if any of the subnet is mapped? Subnet means that 1.0/24, and that has been mapped to 100.1.1.0/24. What happens in this case? So in this case, the first IP is mapped to the first IP of the 101. It's like 10.1.1.1 is mapped to 100.1.1.1. 10.1.1.2 is mapped to 100.1.1.2. So that's how it is happening, like one-to-one mapping. And similarly, if I go to the bottom, then 10.1.1.254 is mapped to 100.1.1.254. Perfect. Does that make sense? So that's how it's like, from one subnet to another, complete subnet is mapped, or one to one is quite clear. You are quite confident with this. Perfect. What if we are having, let me just switch to the lab first and then show you some more examples. Yep. And let us see the concept of, how the packet is traveling and what is the source IP and destination IP. So let us suppose we are having one computer here, and it is having the IP address of 20.1.1.1. So this will be its source IP, correct? And once it is trying to hit any of the IP address, let me take here as 100.1.1, which is standing on this interface Ethernet 1, which is the public facing of our firewall. So the destination IP on this computer will be the 100.1.1.1, correct? Now this complete packet travels to the firewall and reaches it here. Once it hits the firewall, what happens to here? It is being translated. It is being translated. This time, what will be the source IP? The source IP will remain same as 20.1.1.1, but the destination IP on this, after it has gone through the firewall, the destination IP is going to be 172.16.1.10. Now this packet reaches to the firewall, right? Obviously it is reaching to the firewall, and it says, just checks that okay, it is requesting our web page. So it has the information of the web page, and now it is replying back. Once it is replying back, then what will be the its destination IP? Let's say, first say the source IP. What will the source IP? The source IP going to be 172.16.1.10. What will be the destination IP? The destination IP will be 100, not 100. The destination IP will be this one, 20.1.1.1. Correct? Now this IP reaches to the firewall and it is traveling to the outside of our internet, right? When it is traveling to the internet, what will be the source IP and the destination IP? So now the source IP will be the, you confused, right? The source IP will be the 172 or the some other thing. Exactly, because this is not the public IP, right? So the public, it will be translated. Again, it will hit the no another rule of the firewall. I will just show you. But the IP address will be the public one, 100.1.1.1, and the destination will be as it is 20.1.1. Why it is happening? Let me just clear it and show you. If you see the rule here in the firewall smart console, for the NAT rules, we are having the two rules. You see that automatically created. So whenever the packet is traveling from the source to destination means from any computer to the web server, then this rule will be used. In that case, let me hide it. Yeah. So now if you see it here, if the packet is traveling from NAT to web server, means the request has been initiated from the computer. Request has been initiated from this computer to the web server. It's like computer to the firewall. In that case, the translated source will be as it is, means that our IP address was 20.1.1, but the translated destination will be the 172.1.1.1. Correct? This has happened, and then the packet has traveled through the firewall. But what happens in the reverse case? Whenever it is the reverse case, means from the web server to the NE, then what it will do, it will translate the source, it will the destination, that means the destination will remain the translate the destination will remain the same. The destination was 20.1.1. It will not change that one, but it will translate the source of the web server. So earlier it was the web server IP address was 172.1.1, but now it will change it to the 100.1.1, what it was earlier. So that's what it happens, means that all both the rules will hit. So this is the rule whenever the packet is coming from the outside internet user to our web server, and this rule will hit whenever the reply is going and the packet is traveling from web server to that user in the internet. So that's how it is happening. Let me just clear it. 7 and 2, perfect. And anything else I can show you here? The manual rule and the port forwarding. So I think let's keep that one for the next session. Otherwise, if I cover it here, so this will be going to be very long. So let me stop right now, and I will cover the port forwarding and the manual NATing. So both I think in one session they should cover, but if I feel that it is taking long, then I will split in the two. So it's okay for the day today, and let me stop here. And if you have any questions, then do reach me via different methods, either Instagram or comments in YouTube. I will be happy to help you in sorting out your queries. Okay, and yeah, and for the more details, you can see the descriptions. I will be giving more details that how to reach me. Okay, guys. Thank you so much. See you soon in the next session.